quick little project for you to do on the weekend. So we're going to be replacing our USB adapter here. This is a Blue Sea Systems dual port 4.8 amp USB outlet. Traditionally you would use this to charge an iPhone or an iPad, keep your iPad charged up while you're flying around. The issue though is that newer devices use USB-C with power distribution or quick charge. So here is a GoPro, and you can see here it uses the USB Type-C adapter. And also iPhones, although you still use the standard Lightning connector, if you have a wire that goes from Lightning to USB Type-C, these will charge twice as fast. So I found this device here from PowerWorks. It's a similar device to what's currently installed, but it has two different ports: the USB Type-C with power distribution and the USB Type, I guess that's Type A, with quick charge. So I believe Android devices, if you plug them into quick charge, it will negotiate the higher voltage and charge those a little bit faster. So I think the plan of action today is to simply remove these 4 screws, reach underneath, remove the 2 wires connecting this USB plug here, and slide this one into place. So let's see how that goes. Very nice. We've removed the ring underneath, popped it out. Now, as long as it's facing the same way, where the front of the connector is facing forward like this, the negative will be in the same spot. Similarly, this same thing facing forward, negative is going to be in the same spot. Okay, so when you're replacing these units, just keep in mind that the new unit here is slightly shorter than the old unit. And also the dimensions, the width is a little bit different. So on the old unit, we're looking at 1.032. On the new unit, we're looking at 1.039. Now that may seem insignificant, however, the hole that is in that piece of metal right there, it's so exact, you're gonna need a Dremel tool just to expand it just a hair. And then down the road, if you ever wanted to go back to this old unit here, the hole is gonna be small enough still where you can put this back in and it's not gonna rotate around. So we've used our Dremel tool here. We've taken a cloth, we've put it underneath here just to catch any debris. We took our Dremel, went around this maybe for 5 seconds or so. We removed approximately, I would say probably about 1/100th of an inch of material. And now our new USB device fits right in pretty nicely. It does move around a little bit, that's okay. We're gonna tighten this down with our ring, and then we'll reconnect those wires underneath. All right, so there you go. New USB adapters installed, wires connected, firmly secured underneath with that ring. And now it's time for Mr. Screw Gun here. And that's it. All told, I think this should take you maybe 10 minutes at most. And again, the really nice tip is just to remove these screws on this cup holder, not to remove all of the screws for this entire panel here. Hey guys, so a little bit of post-production audio here. Here's a chart of the different power specifications of the various USB specs. The original USB 1 that nobody uses was 250 milliamps, but for the most part, most devices, most USB ports are USB version 2, which is what you will find on most of your kind of older PCs. We're looking at 0.5 amp for those. USB 3 and 3.1 is a little bit newer, provides a little bit more amperage, but again, you're limited to 5 volts. USB-BC is the battery charging standard. Again, you can't transfer any data over BC, but it provides 1.5 amps. USB Type-C, which is more modern, most of your newer PCs will have USB Type-C. That's the oval plug that you see on some PCs, and this power adapter that we saw here in this video. Standard for that is 5 volts, 3 amps, or 15 watts. But again, you know, things are power hungry, so they came out with the USB PD standard. This is an open standard. The manufacturers don't need to do any licensing or any of that garbage. And essentially what happens is the device, the cable itself, and whatever, you know, supplying the power, whether it's a computer or a power brick, they all negotiate the voltage and the amperage limits that can be provided. Essentially, the power brick provides a list of voltages and amperages to the device, and then the device selects the best voltage and amperage it needs to power its battery in the battery's current state. So it's not as efficient as the QC standard, but again, this PD standard, you will be able in the future to power a monitor or a keyboard or even laptops with this PD standard, because it does go up to 100 watts. And again, the device that we've installed in the RV12 only goes up to, I believe it was 12 volts times 1.5 amps. So we're not going to be breaking any circuits or fuses or anything like that. So I hope you enjoyed this video. The next video to come up is a retrofit installation of a autopilot in a Legacy RV12. So keep it here.